Hi, my name is Kelly Schmick, and this is my Unit 3 presentation over the extinction of North American megafauna. So throughout Earth's 4.5 billion old lifespan, species of plants, animals, and organisms have all fell victim to extinction. For the most part, these extinctions occur in waves and are caused by natural occurrences such as volcanic eruptions, changes in sea level, or meteor impacts, but have been because of a wide range of things. However, the last substantial extinction occurred in the late Pliocene epoch, about 12,000 years ago. During this time, continental movement was very low, and the continents were relatively in the same place as they are today. The glaciation period was ending, and Earth's temperatures were rising. Also during this time, the first people were migrating to North America. These people were known as the Clovis people. This extinction was known as the late Quaternary extinction and occurred worldwide, but mostly more abruptly in North and South America than any of the other continents. During this extinction, nearly half of the megafauna population in North America became extinct, and the cause is still unknown. So animals who fall under the megafauna category are over 40 kilograms and include saber-toothed tigers, mammoths, giant ground sloths, and dire wolves. Though geologists have multiple theories as to why these giant animals became extinct, it is still a controversial topic in geology today. Also, an interesting one if you research the topic a little bit more. So, one theory as to why megafauna went extinct points to one of the first human groups to step foot in North America. These first immigrants were known as the Clovis people, and they traveled through a corridor and past icy sheets that cover modern-day Canada about 13,500 years ago. They came with a readiness to hunt the megafauna with their large spearheads that are part of the Clovis technology. So these spearheads have been found in Clovis sites across North America, mostly in Arizona and Northeast America. So the proportion between decreasing megafauna and increasing human population during this time was negatively correlated for thousands of years, maybe 1,000 years. Another reason the megafauna became extinct so quickly is because the early humans who started hunting them were able to, they started in northern North America, and they were able to move southward at a very fast time. They covered thousands of kilometers in about 350 years, hunting the megafauna to extinction in their path. So the process of hunting the megafauna to extinction is known as the overkill theory, founded by geologist Paul Martin in the 1960s, I believe. It is thought that the Clovis people were highly successful in hunting because the megafauna were slow-moving animals that were innocent and naive to the hunting practices the Clovis people had perfected. Along with that, the megafauna typically had slower reproductive rates that made it difficult for them to replenish their declining populations. Their gestation period was also longer than a typical animal, which also hurt the reproduction in that aspect as well. Though they had a negative relationship, the two Clovis people and the megafauna coexisted for a short 1,200 years before the megafauna became extinct. So most of the megafauna lived in North America, lived in places that were difficult for humans to reach, such as trees, mountaintops, or deep in the forest. One likely reason that these megafauna liked to live in these places was because it created distance from their human predators, which makes sense because you'd want to get away from your predator as well. Island-based and continental extinctions also show comparison, a different between one another. For example, megafauna who were lucky enough to live on remote islands typically survived longer than those megafauna who lived on the continents. That is until humans migrated to those islands, but that wasn't for hundreds and hundreds of years. One example of this in effect is the life of the giant ground sloth, who lived in the West Indies. Humans didn't settle in the West Indies until the middle of the Holocene era, which is the epoch that we are still currently living in today. They settled around 6,000 years ago, well past the late Quaternary extinction of megafauna. So ground sloths in North and South America had been extinct for thousands of years. However, the sloths in the West Indies survived well into this epoch before becoming extinct, it is thought, upon human arrival. So this shows that there's great evidence in the argument that human hunters were responsible in the extinction of the megafauna. The extinction of the species had a negative effect on other species of animals as well. In plants, human hunting could have resulted in predators switching to other forms of prey because of the heavily reduced number of megafauna. Or megafaunas that were still currently living through their other genre and similar species dying or becoming extinct. These predators looked towards large herbivorous animals to prey on, which then led to a decrease in the herbivorous populations as well. So in total, the predator and prey populations both decreased to human hunting megafauna. Animals all over and all types starved and struggled through this time. So, for as long as the megafauna extinction has been researched, the overkill theory is thought to make the most sense. This is because it's easy to understand and it blends right in with the idea that we are the dominant and most powerful species. Also, the types of food were available were relatively short, so they needed something to live off of, which in this case points to the megafauna because they were large in size and carried a lot of meat that the humans could eat. So, but in most cases, there are some who argue that the human hunting theory is the incorrect theory. They argue that there's not enough evidence to support that humans were responsible for the extinctions. So of over 36 genera of megafauna that went extinct, only 2 show evidence of being hunted by humans, such as the cuts in their bones from the Clovis technology and their spearheads. These 2 megafauna were the woolly mammoths and the mastodons, and have been found in only 14 of about 46 Clovis kill sites that have been found in North America. So this leaves genre including saber-toothed cats, tapirs, giant beavers, as well as other forms of megafauna with 0 known kill sites. This means that we have no proof that human hunters and these megafauna were had a relationship at all, whether that was hunting or whatever. So it is believed that the overkill hypothesis lives on because of people like me and people with no geology background repeat the theory down generations, and not because archaeologists and other scientists and paleontologists confirm it as true. So, in addition, scientists have gathered radiocarbon data from 47 different megafauna kill sites, and from 47 different megafauna kill sites, as well as 22 Clovis people kill sites. I'm not really sure the location of these 2, if they are together or not, but the findings have shown that most of the megafauna had already disappeared before humans arrived in North America. So these findings also showed that megafauna suffered from two major declines in population before going extinct. The first decline occurred about 14,100 years ago, hundreds of years before human arrival. So in the second megafaunal population recovered, about around 500 years after the first wave of population decline, but then a second wave of decline occurred 12,700 years ago when humans had just arrived in North America. So the findings showed that megafauna and humans coexisted for about 1,000 years before megafaunal extinction. However, 75% of megafauna were extinct prior to humans' arrival to the Americas. So, switching gears, there's another theory of why megafauna went extinct, and that is due to climate change. Not surprisingly, it's a common issue in geology forever. So, during the late Pleistocene, the world transitioned from glacial to interglacial condition. This increased temperatures to about 45 degrees, and as we entered the Holocene epoch. The warmer climates accompanied by changes in rainfall may have been a reason for extinction. The increase in temperature most likely put a stress on the megafauna that had adapted to the extreme cold. They had thick fur, and it would trap their body heat in, affecting their health due to the heat. So this caused many species of megafauna to die because of heat exhaustion. So vegetation changed due to different climates as well. The environments went from lots of forests to grasslands. The new vegetation brought new forms of food, which was mostly bad in the case of megafauna because they were used to a certain type of food and now did not have adequate forms of prey. When the megafauna weren't getting enough suitable amounts of food, many starved to death. Others, such as the bison, survived because they are ruminants, or animals who can extract more nutrients from the food they eat, resulting in them not having to eat as much food. So along with that, the rainfall and vegetation also changed their reproductive season. Megafauna were forced to give birth to their young in times that were not adequate for water and shelter. Sometimes they weren't able to access that. That led to many of the megafauna in their young to die of starvation. So some genre of megafauna, however, adapted to the high temperatures and low quantities of food by growing smaller over time. For example, the wild horses in Alaska showed a decrease in size, as well as some bison. The dwarfing of these animals allowed for them to need less food and body weight to keep cooler during the post-Ice Age climate. So critics have also argued against the climate change theory because herbivore megafauna such as horses and mammoths should have prospered during the change because grass was more abundant than before, yet they still became extinct. Other herbivores had lived through continental changing climates as well, but became extinct during the very similar climate of the late Pleistocene era. Also, it is an innate behavior for some animals to migrate when temperatures are cold or food is scarce. However, the megafauna in this epoch failed to migrate, which is weird in science because they should have migrated to better places. Another slightly less popular theory of megafauna extinction is the hyperdisease hypothesis. This hypothesis suggests that the hyperdisease was unintentionally brought to North America by the newly arriving people or their domesticated dogs who had recently crossed the Bering Strait. It is also this disease would have been fatal to all to megafauna yet dormant inside of the people carrying the disease, because there is no sign of this disease or this possible disease harming humans at all. So the megafauna's lack of exposure and low ability to adapt to the disease would have put them at a very high risk of catching and becoming extinct from it. Smaller animals were not affected by this, and it is thought to be because of their low reproductive capacity, or because of their high reproductive capacity and their shorter gestation periods. They were able to reproduce faster than they were dying of the disease. Although this theory does not have much evidence to show whether it is false or true, scientists are still continuing to work to find evidence. The most recently formed hypothesis suggests that a collision with a group of comets striking into a melting glacier somewhere above Canada, near the Canadian Great Lakes, about 12,900 years ago, was thought to may have been responsible for megafaunal extinction. The collision formed a new period known as the Younger Dryas that spanned from 12,900 years ago to about 11,700 years ago, where Earth went to a short cold period. During this period, 15 species of megafauna and arguably the Clovis people went extinct and have no evidence of fossil record. In total, the lack of evidence of population decline among the people during the Pliocene is the landings are argued. For this comet theory to be true, the megafaunal extinctions between continents would have needed to be synchronous, but they were not. For example, the extinctions in South America occurred about 400 years after the North American extinctions. Similarly, some genre of megafauna survived thousands of years longer than related species. A comet strike is typically known to wipe out everything in its path, but it did not in this case. So the evidence debunking this hypothesis weighs more heavy than the evidence that shows that it could be true. So the true cause of the great megafauna extinction remains a mystery, though the question is hidden under a variety of theories. The only way to further our knowledge and become closer to the answer to this topic is through more research. If scientists could locate more kill sites, they could more fully examine the bones and possibly the bones and other things that the Clovis people held on them. So new technology and use of computers helped simplify the situation by being able to recreate computer simulations to test these theories electronically. They were also able to study pollen records and analyze change in vegetation. So far, the studies have proved inconclusive, but further research is still ongoing.